Number 16. Classify each of the following as an element, a compound, or a mixture, and then I see we have A through H. So the first thing that I want to do is I just want to write down A through H over here. So A, B, C, D, E, F, G, and H. Okay. The next thing I want to do is I want to just tell you a little bit about the differences between elements, compounds, and mixtures. You should know these, but let's just refresh just to get the hang of it. So just know that from smallest to biggest, elements would come first. So elements are the smallest. Then comes compounds. And then comes the big mixtures. And they kind of piggyback on each other. An element is any one box on the periodic table. So if you just said boron, and it's just boron, it would be an element. Or fluorine, it would just be fluorine. There are some exceptions, and there's probably going to be an exception in this list, so we'll get to it when we get to it. But just for now, one single block would be an element. So boron, fluorine, etc., etc. Then it kind of piggybacks. So when you have multiple elements, you will make a compound. So a compound is just multiple elements coming together. So now you're picking up two or more blocks or squares on the periodic table. So this would be water, H2O. You picked up hydrogen and oxygen. Those are two separate squares on the periodic table. Hydrogen's over here, oxygen's over here. There's so many different compounds. And then it piggybacks from there. Mixtures are just multiple compounds coming together. So you see how that works? Mixtures, remember, it could be heterogeneous or homogeneous, but it just has to be two or more compounds coming together. So salt, water. Literally, you have the compound salt, NaCl, plus water, which is H2O. In this case, you have two compounds. They came together and they formed a mixture. Now we just got to figure out what A through H is all about. So for A, copper. I would like to start from the smallest and work our way down because I think that's the easiest way. So the first thing you should say to yourself is, can copper be found on the periodic table? And yes, it can. It is right here. Cu is copper. It's a single square on the periodic table, so therefore A, copper, is an element. So that checks this one off. B, water. What do we know water is? Oh, well, water is H2O. And just like we said before, here's water. Water is a compound because it contains two different elements. So B is a compound. Okay, that gets rid of that one. Nitrogen. Can nitrogen be found on a single box on the periodic table? Yes, it can. It is right here. N. N is nitrogen. So it's got to be an element. Keep going. Can sulfur be found on the periodic table in just one box? If you scanned it, and you'll see that it's right here, sulfur is just an S. So I'll put that nitrogen was just an N, sulfur is just an S. So it's a element. Halfway through, air. Ooh, this one's a tricky one. So air, if you looked it up on Google, or if you're not sure what air is, it's actually many different molecules coming together. In air, you have oxygen gas, O2, the stuff that we breathe, but there's also a lot of other things in there. There's nitrogen gas, etc., etc. But this should kind of give you the hint as to what's going on. In this case, there's two separate things that came together. So it can't be an A element because there's oxygen and nitrogen. Can't be a compound because they're not specifically together. They're two separate entities that came together. So this has to be a mixture. Two or more molecules came together to form air. Okay, next one, sucrose. Sucrose is, I believe it's table sugar. Just sugar in general, so it's a more complicated form of glucose. So sucrose is actually C12H22O11. Element, compound, or mixture. Definitely can't be an element because it's carbon, hydrogen, and oxygen. So you're hitting 3 different boxes on the periodic table. But they came together to form one single entity. It's not 2 different things that came together. It's your carbon, hydrogen, and oxygen came together to form one, you got it, compound. So F, sucrose, is a compound. Almost there, guys. G, a substance composed of molecules in which each of which contains 2 iodine atoms. Element, compound, or mixture. Now this one, I'm going to put a star here. This one's actually the tricky one. Now here it's a substance that is composed of molecules, but it's only 2 iodine atoms. These are the same atoms. They're not different atoms. An atom, like we said before in the last couple of questions, are a single square or a single block on the periodic table. So here, we're only talking about iodine. So it would just be iodine, which is found over here on the periodic table. So if it's just iodine, doesn't matter that there's 2 iodine atoms, it's still only iodine, 1 block, so it would be a element. That one was a tricky one. And last but not least, gasoline. Gasoline, if you looked on the periodic table, it's not a single block, so element is automatically out. But turns out that gasoline has a whole slew of compounds. There's actually, I think, about roughly 150 compounds in gasoline. So a lot of them are going to be organic compounds. You don't really necessarily need to know that, but they have cool names. So butane would be one compound in gasoline. Pentane would be another compound. Benzene. These are all cool names, but each one of them has its own distinct chemical composition. Butane is C4H10. Pentane is C5H12, and benzene is C6H6. But there's 3 different compounds coming together to form gasoline. I just wrote 3 here, but just know that there's actually about 150 compounds that come together to form gasoline. Crazy. So, since that's the case, gasoline has to be a mixture. All right, guys. Awesome job. Hope this helped. If it did, hit that subscribe button, and I'll see you all in the next question. Have a great day. See you later.